The vast majority of people out there, this is too dangerous, not to mention a total waste of time. This really doesn't make sense. You should probably just buy a new battery bank. But we wanted to do it for fun because it gave us an excuse to make one of these. This is something that I have wanted for quite some time for unrelated projects, a DIY spot welder. Let's fix a battery bank, shall we? From the cell swap, which is my half of this job, we need to go back in time and far away to the Linus Media Group warehouse this morning, where Colin was working on our DIY spot welder. It's fairly inexpensive to build one of these. All you need is a power source, a relay, a switch, and some big old heavy gauge wiring, and a little bit of time. He's gonna show you how you can build one of these for yourself step by step, then throw it back to me to find out if this is actually going. There are a couple of other routes we could have gone for our project. We could have bought a pre-done battery tab welder from overseas, but we decided that given the relatively small amount of spot welding we're planning to do, we could DIY our own solution for minimal effort and probably less money. Instead, we decided on the safer route and built an all DC power spot welder. So for that, we need a battery. We used this 12-volt ATV battery capable of outputting the high current needed to make the welds, while also being a bit more manageable than a car-sized one. But we can't just have two live leads coming out of the thing. We need to be able to reasonably precisely control the application of power, which is where this starter relay comes in. This relay is able to quickly switch the high current circuit of our welder on and off without being damaged.
So these two terminals are what activate the relay, and these will be connected to hot and ground as well, but this is where the actual current goes through. So we want to bring hot down to here and then hot out to our little contraption and then negative back in.
If we were to try to use a little toggle switch, for example, a huge amount of current would flow through the switch, letting the factory installed blue smoke out and creating a nasty electrocution hazard. Instead, we'll let the big relay do the heavy lifting and use this smaller momentary switch to briefly pulse the power on and then release it. With the relay and battery mounted, it's time to sort out the wiring and the electrodes that will actually deliver the current to the nickel strips. We're using big 4-gauge cables that you can find at any automotive shop for this. 4-gauge wire is capable of carrying 250 amps over a 4-foot distance, meaning we are well within our safe range here. With the ring ends crimped onto the cables, the last thing to sort out is the electrodes themselves. But first, some safety stickers from lttstore.com. Nice. We chose to use copper for our electrodes because it's able to both handle the power and high heat at the weld zone while hopefully lasting a reasonably long time. Once we had our two pieces clamped in vice grips, a short trip to the belt sander resulted in nicely pointed ends that should work great for our electrodes. A quick crimp and some heat shrink for safety, and the cable assemblies are ready to go. After pairing the electrodes up and some brief troubles getting the fence installed, Colin was able to give the welder its first test run.
And contact. Well, I blew through the strip.
And on that first attempt, he did not get a successful weld. But after a little bit of practice, he started getting good, consistent spot welds. More than enough for what we need. So the rig was packed up and dropped off back to me where, well, this is where we pick up. It's nighttime now, my kids are in bed, and I am ready to fix up this battery bank. For this project, I'm gonna need some safety glasses, a digital multimeter, some nickel strips, a cutter to actually take it from one big long strip into multiple strips, my pink battery bank and my DIY spot welder, of course, and some of these commodity 18650 cells. These are actually the same ones that I used for my DIY souped up Power Wheels battery a little while back, but fortunately they've been sitting in storage at around 3.62 volts, which is well within the safe storage voltage for these. And this is another really critical thing. I have checked all of these 18650 cells with my multimeter to ensure that they are all the same voltage, because you can run into some real trouble when you start spot welding together batteries that are actually at a different storage voltage, because all of a sudden you're gonna have them equalize nearly instantly and they can get super hot. That can be very dangerous. Oh, one thing I didn't mention is that I've got a couple of dead D-size cells that I'm gonna be using to practice my spot welding, because unlike Colin, I haven't actually taken a run at this yet. So we're gonna go ahead, chuck that on there, cut a nice little tab of nickel and see if we can get a spot weld here. Ooh, hi! Okay, so if you don't go long enough, they don't stick together. And if you go for too long, you blast right through your nickel strip. Oh, not quite, dang. Oh, hi. That is on there. The advantage of spot welding versus just soldering our battery pack together is that we apply heat to join the metals for only a very short period of time. When you solder, you have to heat up the solder itself and flow it onto the materials you're trying to join, which can mean that they can heat up quite significantly. Heat kills batteries. So this is a way for us to much more safely assemble our multiple cells into a battery. One other thing to note to do with that heat kills batteries is make sure that you get genuine nickel strips. Sometimes you're gonna see steel strips with nickel plating advertised as pure nickel strips. And the problem with that is that steel is not quite as conductive as nickel. So what happens is, especially if you've got a high current battery pack, probably not a concern for us here today, but if you're working on like an e-bike battery pack or something like that, it can heat up more, which can heat up your battery pack more and slowly kill it. With the pre-done ones, you can just sort of dial in how long it goes for and then kind of play around with it until it's just right. But here I just gotta kind of eyeball it. Come on. Yep, nailed that one. All right, let's go for it, shall we? Now that it's open, we can see the configuration of the battery packs. It's 2S, 2P, which means we've got 2 cells in series and then 2 of those in parallel. So series gives you voltage, so you need at least 2 to get above 5 volts for USB charging. And then parallel gives you capacity. So this gives us the total capacity of 2 18650s. I lied, there's more stuff we need. Captain tape, solder, flux, soldering iron. These old cells were a little less worried about damaging with heat because they're like kind of dead already anyway. So we're just gonna desolder them real quick like that. You can see here I'm gonna have to do a total of 4 + 4 spot welds with 3 strips. So a strip here, strip here, strip here, and strip here. Here's where it gets real. Wish me luck, hey? Oh, so close. Whoa, 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 hi. Okay, yeah, you're done. That's bad, that's terrible. That's going outside now. No, 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 why are you going for so long? I let go. So the switch flaked out on me, but I'll strip here. Here's where it gets real. Wish me luck, hey? Oh, so close. Whoa, 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 hi. Okay, yeah, you're done. That's bad, that's terrible. That's going outside. No, 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 why are you going for so long? I let go. So the switch flaked out on me, but it seems to be behaving properly again. Oh, got it. Yes. Okay, but while one of those did burn through on this one here, the other one's good. So we're just gonna give it another spotty spot. Oh yeah, oh yeah. We good, ladies and gentlemen. Nope, that's a little hot. One of those burnt through a little bit, but the other one seems okay. I think that should be enough. We'll give it one more after it's cooled down. That one's on there though. Okay, that's a little harder. Okay, I think I got it. It's not the finest workmanship ever, but it's the same configuration as our original battery, so we should be good to go. Oh no. The original battery had extra length on these 2 strips to solder to. Removing these is not going to be easy. Basically, you can't. We have a couple of different approaches that we can take. We can either solder directly to this strip right here, which is probably fine, except that it's going to heat up the battery, which is not what we had intended to do. Or we can try to spot weld another nickel strip on top of the original one. What do you vote for?
Spot weld.
Spot weld another nickel strip? I'm sure the internet comments are going to be full of why you shouldn't do that, and you probably shouldn't. Okay, that was perfect. Now we got tabs on the end for soldering. Now all we need to do is solder the electronics to the original pack. Good enough. So we just fold these tabs down, make sure they're still on there real good, and we can solder the pack back on. Okay, good, 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 good. Hold it. Now that our solder joins are good, I'm gonna go ahead and just throw some Captain tape over all of those solder points You know, last thing we want is this strip coming loose and shorting something on the PCB or something dumb like that. Let's pop that in there. We're gonna go PCB side first. That's it. Hey, all right, cool, okay. To check our sanity, we're just gonna put a couple of probes into a USB port on here and see if we get 5 volts. It doesn't power on. Oh, I wonder if my ground connection is just no good. 7.25 volts. That is correct. So let's grab our original one. 8 point something. This is more charged than this one. So yes, our battery is fine. Where we're running into trouble seems to be where our BMS is connected to the battery pack. This to here should be 7 point something volts, and it's wonky, it's all over the place. So there's just a bad connection. So now we're gonna probe our solder joint here and our other more different one. Now there's your problem. If we go to the back of the cell, we've got 7.2 volts. If we go to that glob of solder we got there, we've got sometimes, but also on this wire, we have not. Get this off. Okay, I just checked the solder points on the BMS and it seems like it is now attached better. Everything that I can see says there's power to the board. I've got my 7.2 volts, but I pressed the button and it just came alive. You know what it probably was? It's only got 1 bar, so it's actually a very narrow voltage range that most of these types of batteries operate within. So we were probably at the threshold where the thing won't turn on at all. You know, what's funny is I had planned to bring this out as my kind of last resort. You know, cut my life into pieces and all that, and see if I could charge it up, and then it would come to life. So it might have just been so dead that the battery indicator wouldn't even work. So let's plug this in. It's charging. Charging. We did it, Reddit. Reassembly time. There we go. Okay, so we glue it shut. And there it is, working as intended. You know what I should do? If I love Captain Tape so much, I don't have a D-brand tutorial to watch or anything, but. Well, I hope this was as fun for you guys as it was for me. Once again, to be clear though, I'm not recommending doing this at all if you have a 5 or 6 year old battery bank.